Hello everyone. As I said in the previous video, you need to maintain the weight balance on the rear side of the robot. So if you observe, this is my front side where I have the sensors, and this is my rear side where I have the battery. So that even though if you take these motors on the center line, then the only chance where this robot is going to rest is on the rear side because of the weight that you are putting on the top plate in the form of a battery load. So this care you need to take that this battery falls near about at least uh, 3/4 of its weight on the rear side, so that you're going to be always sure that you won't fall forward uh, on your sensors whenever you are actually placing this on the surface. So what I did here is I got this battery on the top plate. I got the positive and negative taken through these two holes. So this one is for positive and this one is for negative. So the negative wire is, the brown one is going to be connected to the ground terminal of this motor supply. So I got a ground pin here and I got a motor plus on the top side. So the negative terminal of this battery will be connected to the ground pin, whereas the motor plus or the supply plus pin is going to be connected to this red, and the red cable is going through the switch taken through the hole to the positive, so that whenever I turn on this supply, the battery supply will be given to this particular block terminal of the shield. So that's all the job of this particular bottom plate and the battery holder. So let's keep them aside. Now imagine that I'm already getting supply through this wire, so I'm not going to connect it here just for the simplicity of making this video. As an alternative way, you can use some sort of adapters, maybe a 9-volt wall adapter for testing purposes, and later on port onto your battery system. As of now, what I have on this board is I got a sensor board and it has digital pins. Let me focus a little bit. So I hope you are able to see this. Okay. So what I have here is a complete analog set, that is A6 to A1 and 5 volt and ground, or alternatively what you can use is this 5 volt, the plus 5 volt, and D1 to D6. So I have preferred using this ground, VCC, and the 6 digital pins that are coming out of this IR sensor array. As you can see, I have simply used few jumper cables and I have attached a black tape on this one, so that I need not to uh, rethink like which pin is connected to what. So this is what you can do. So let me show you the other side. So these are simply the jumper cables, and I'm sure that they won't fall off, and I have to always connect the same set of cables uh, all the time. So put them in order, proper order, and then simply apply some sort of tape so that they stay together, and it would be very easy for you people to insert all the 6 cable at once. Now I got these uh, 6 pins coming out of the 5 volt ground and D1 to D5, whereas the 5 volt and ground pins I have taken separately. So now the only thing that you need to take care is make a couple of grooves in between the two motors. Make sure that the wires won't come in between the wheels so that you will never stuck whenever you're traversing the path. And take them properly on the top side and keep them ready so that you can connect it to the shield. Now, this set of 6 cables are coming out of my IR sensor, which are the sensor's output, so that whenever your sensor comes or it encounters with a black surface, it is going to send me a 1. So imagine that I'm currently placing all the sensors on white, as I'm having a white surface on the ground. Uh, all the sensors, like all the 6 pins, are going to give me a 0. So I'll be getting a 0 on this pin, so that whenever I'm connecting these 6 cables on these analog pins in this way, then if I read these 6 pins by using my Arduino software that I'll be loading into this IC in a couple of minutes, every pin is going to actually show me a 0 reading. On the other hand, if I have a black surface on all these sensors, then all these 6 pins are going to give me a logic 1 reading. So if I do some sort of digital read and I try to read the sensor values in my Arduino software, then they'll be reading 1. So I'll be showing you this in a couple of moments. So this is how the things are happening. And the VCC and ground must be connected on these 2 slots, which are already given. So let me quickly connect it. So I got the ground first, then I got the VCC. So you won't be getting these bird strips already soldered whenever you are purchasing this for the first time. You need to uh, get these bird strips and solder them from the bottom side. So now you got 2 options. Either mount this on the bottom side of your top plate so that whenever you open it, this is the way how you will be able to open this. Or alternatively, mount this board on the bottom plate itself. So what I did is I have used these spacers. Make sure that it's my very strong recommendation that you always maintain proper space between your Arduino board and the body. If you are using a metallic chassis, then do take care that you are using some sort of glue or some sort of spacers, or alternatively you can apply some tape, an insulating tape, to insulate all these bare pins that are available on the bottom side of your Arduino. Otherwise you're going to burn out this Arduino board, which usually happens with any kind of a beginner. So I have already mounted a couple of screws just for holding this Arduino board. Alternatively, you can directly use a glue stick and glue it up. Now let me mount it. So let me pull these wires a little bit outside so that okay. So this is how it's going to look. So if I'm very much sure that I need not to pull this board out again, then I'll be using some bolt or a nut kind of a logic to completely fasten this screws. So as of now, I won't prefer to completely fix it up. So I'll simply try to push these wires a little bit inside so that they won't come in between. Now, the other important part is we have these 2 motors and we got 2 terminals on both the sides. So we need to take these 2 wires, solder them properly. So I'll be having positive negative of left motor and positive negative of right motor taken through these holes coming outside. As I have already told you in the previous video that I'll be using M3 and M4. So just get those wires out and put them inside these M3 and M4 slots. So let me quickly do it. So that's the reason why I didn't fix these things. So it will be easy for me to hold and unscrew these things, and make sure that you are having 5 pins, 1, 2, 3, 4, 5. But this is where M4 is written on the right, on the top side. So pin number 1 and 2 actually corresponds to few of the outputs of this IC, and this is where M3 is written. So pin number 4 and 5 in this particular slot uh, actually resemble 2 pins of this motor section, whereas the center pin on this side and the center pin on this side, they're resembling actually the overall ground of your circuit. So you can use some sort of multimeter and verify like which 2 pins are connected to which pins of your IC directly by tapping the uh, terminals of your IC. So the center pin on this slot and the center pin on this slot is useless, or you can simply use it for grounding. So make sure that whenever you're connecting it with the motors, you won't use that ground one. So let me put them one by one. So gently pull it off and verify that they are properly attached. So sometimes it becomes a little bit difficult for you people to insert it because I already cut these wires and they are very short, so it's a little bit difficult to insert those wires. So make sure before you cut the wires you have enough amount of length for it. This is a very boring event though, but it's a one-time activity, so you can actually take few efforts to put them in finally. Okay, so I got the second one. And last, okay. So make sure that you are properly inserting all these wires. There should be no bare wires coming outside. Otherwise, if you short these two uh, plus and minus of the motor, then probably you're going to burn up with your motor shield, Arduino, and everything. So just take a couple of precautions whenever you're making it for the first time. Okay, now I got everything back in place. Now finally what we have, a bottom plate with two motors attached along with the bow type wheels and a caster and an IR sensor. So the important part of this is you need to use certain screws or spacers so that this sensor has near about uh, 3/4 to a complete centimeter kind of a distance between this one and this ground surface. So as you can see, I have near about 1 centimeter gap between the surface and the sensors. So that's how you're supposed to adjust this one. This is a very important part. If you are keeping them very much above the ground surface level, then these won't sense them properly. Or there would be some sort of crosstalk between the sensors. Whenever this sensor is transmitting the line of light, then there are chances that it would be actually sensed by the secondary. So the nearer you place it with the surface, the better is going to be the resolution and the accuracy of your sensing. So after this sensor, you got an Arduino and Arduino shield, which is connected to these analog pins. The VCC and ground of your sensor is also connected properly. Just let me verify it. So 5-volt ground and 6 pins. Okay, fine. And you also have these 4 motors connected properly. Now, imagine that you are programming this particular robot and you are writing the code to move it forward. But for some reason, if it is moving in a reverse direction, just identify that this motor is the right motor and it is connected to M4. Then simply reverse these two wires. Then it would start rotating in the reverse direction. So you need to work out a little bit on the directions first, like which direction is moving forward, which direction is moving reverse. If you have the desired outcome satisfied, then we are good to proceed with the rest of the coding. Now, we got this Arduino board, which is ready. And now the next part is to learn some sort of coding. So the window that you're able to see here is a simple Blink example, and this is nothing but an Arduino IDE. So what you need to do first of all is uh, go to Tools, select the board as Arduino Genino Uno, because we are using the Arduino Uno board here. So this is the first part, and the second part is if you connect this Arduino board with this cable on one side, and if you connect this other side to your laptop or machine, then it would be recognized like this. Currently I didn't connect it, so I won't be able to show you. The cable is a little bit shorter, so I'll show you this in the next video where you will be able to identify that a port is detected. So for doing that, you can simply type a command or something like go and type the shortcut. It will directly redirect you to the device manager of your PC. And then hopefully if you connect your robot to your PC, you will find a specific COM port under something known as ports. So let's go into this in detail in the next video, but for now, this is what you are supposed to check. If you're unable to see any port or under tools and port, then you are supposed to go to the device manager and identify which exact port it is, and then come back here, go to tools, select the port. So once you are good to Once you're set with this selection of the board and the port, then you can go to File, Examples, Basic, and Blink. Now, the next part is you need to go to Tools and select the board and port. Then go to Sketch, and you're supposed to click on Include Libraries, and then hover your mouse to Manage Libraries and click on that. Make sure that when you are following this particular method, your machine must be connected to internet. So as you're able to see, it will search the online repository of Arduino and give you a list of all the available softwares here. Then here, you're simply supposed to type Adafruit Motor Shield, or simply you can type Adafruit Motor. So the reason why we are typing this Adafruit Motor is the board and the motor shield that we are using. This is actually designed by Adafruit uh, industry, and they are offering us some set of libraries that we can directly impart into our program. So before getting into the real raw coding stuff, we need to integrate the library that is associated with this motor shield. So that's the reason why we need to perform this initial step before moving ahead into the coding. Now, I have already installed this one. In your case, you will be finding some thing like this. So you're supposed to select the latest version, which I have already selected and installed it. So I won't be installing it again. You're supposed to click on this install. And once it is installed, close this button and also close the Arduino software and reopen it so that the newly installed libraries would be reflected in your program now. Now, if you observe the software, uh, the basic and the rough structure of an Arduino based software is this one. So we basically have just two functions. The first one is the setup and the second one is the loop. As you can see, this setup is a function which is very much clear and evident with the help of these two brackets lying empty along with this. And it says void setup. It's a meaning that this function is not going to uh, accept anything. So this function is not going to return anything, and even loop function is not going to return anything. So you can go ahead and change the values and the structure of your overall code, and no matter how many additional definitions of methods and functions you are defining or interested, you can always go ahead and define it. But as long as you maintain these two functions intact in your code, you're good to go with the coding of your robot. So in this function called setup, you are supposed to write everything which you are supposed to just do once. Like I have introduced you with this motor shield where we are going to use this M3 and M4. So whenever we say that I'm using a certain pin, maybe imagine that I'm using pin number 13 of my Arduino board as an output, and then I need to first of all configure my pin number 13 as an output. Otherwise, your Arduino won't understand whether the pin that is being used is set as an input or output. So you need to first of all inform the Arduino to uh, identify and decide that yes, this specific pin is going to be used as an output, and hence we are going to connect some sort of external device or an actuator to this one. So anything like defining the pin mode of certain pin, like I can write number 9 set as output. So this is a simple statement which defines the mode of a pin called number 9 on your Arduino board will be used as an output. That's the meaning of this one. So anytime if you find difficulties in understanding a specific syntax or a structure of your Arduino program, just click on that function which appears something in a orange color, and go to help and click on reference. You can simply type the shortcut called Control Shift F, or click on this find in reference by clicking the help menu. So it must automatically redirect you to your default browser, where it will open some local documentation which is already imparted into your Arduino IDE software itself. So as soon as you click on that one, you will be presented with a HTML document, which is probably loaded offline, which is visible with this one. By looking at the URL, you can easily identify that it's an offline document. So just go ahead and read, like pin mode is a function that configures the specific pin to behave either as an input or output. That's what we have discussed earlier. So if you scroll down a little bit, the documentation is pretty neat, very short and straightforward to the point, and it will be more clear if you look at the syntax and the example, which is actually given on the bottom side of each and every documented page. So that's all about the Arduino IDE. Uh, all one-time activities needs to be written inside the setup, and everything or every instruction which needs to be repeated forever until you apply the voltage or the energy source to your electronic application has to be written inside this loop. So the things will be more clear in our next video. Just stay tuned to this one. Thank you.